Hello everyone, welcome back to my channel, and in this video we are going to discuss BRA654C Module 1 PYQs for the subject called Fundamentals of Robotics under the VTU 2022 scheme. This video is useful for the last minute exam preparation because we will cover all the important questions with the answers point, diagrams and writing exam writing tips. Okay, so watch till the end because I'm going to tell you where you're going to find the notes for this questions, okay, at the end of the video. And do not forget to subscribe to my channel. So let's get started without wasting any time. So this is the overview of the syllabus. First, let you understand the syllabus for the module 1. In this module, we mainly study the introduction to the robotics, difference between robotics and automation, laws of robots, history of robotics, robot components, specification, classifications, human system comparison, safety, social impact, market, future prospects, advantages and disadvantages. For VTU exam, always write the answer in this flow order: definition, then diagram or the table if needed, and then the explanation. Then you can give the examples and conclusion. Okay, so this is the flow of writing for around, if it is asked for 8 to 10 marks, so you can use this flow to write your answers. And wherever possible, draw the diagram neatly because diagrams helps you score more marks. Okay, and another thing I want to mention you here is that the textbook which they have told you, it is not available for free anywhere. Okay, so if you have textbook hard copy, you can just refer the diagrams from the textbook. Okay, so that will be better for it. And if you don't have textbooks, no need to worry. So whatever diagram, okay, the flow diagram, whatever I'm going to give you or in the PPT and as well as the notes, so you can refer those diagrams, okay, for your exam. Okay, if referring those diagrams is also not a wrong thing. Okay, something is better than nothing. You can also refer those diagram for your exams. Okay, so let's get started. So model 1 question. Okay, so these are the questions which I have got from the previous year question papers. The questions include robotics and automations, then laws of robots, history of robotics, robot components, robot specification, classifications. So these are the topic which I'm telling, okay, which you have to read, okay, so that you can score marks for the module 1. Okay, then comes human system versus robotic system, safety measures for the robots, and then social impact, okay, robotics market, future prospects, and advantages and disadvantages. So while studying, don't try to memorize every sentence. Focus on the keywords, diagrams, examples, and conclusion points. Okay, very important. You have to read. Okay, you have to memorize the keywords, diagrams, examples, okay, and at the end conclusion points. Because it's not for the theory subject, it's not mandatory to remember, and it's impossible to remember exact sentence. Okay, even if you read, so you can memorize one question, two question, three question. Okay, you don't have that much time, okay, at last minute preparation. So what you have to do is, for theory exam you have to remember the keywords. You have to remember the keywords. Okay, you can just spell it 10 times and it is going to memorize in your mind. Okay, so yeah, so these are the questions. You can just go through it. So let's start with those questions one by one. Okay, in the slides, I'm going to tell the topic and followed by what keywords you have to use for that specific question. So the first important question is define robotics and automation and differentiate between them. So automation means using the control system and machines to perform a process with minimum human effort. For example, automatic doors, elevators, CNC machines, and conveyor system. So robotics is a special branch of automations where the programmable machine can sense, decide, and physical move using links, joints, and end effectors. Okay, the main difference is flexibility. Robots are programmable and can perform different tasks, whereas automation may be fixed and flexible. Okay, so this is very important. Remember, the main difference is flexibility, where robots are programmable and can perform different tasks, whereas automations may be fixed or flexible. So, the conclusion here is that all robots are automation systems, but all automation systems are not robots. Remember this point. Okay, all robots are automation systems, but all automation systems are not robots. Okay, so this was about the first question. Next is laws of robots. So state and explain the laws of robot. Why are these laws important? So there are three laws. First law says that the robot should not harm the human being either by action or by inaction. And the second says that the robot must obey human orders, but only when those orders do not conflict with the first law. And the third law says that the robot must protect itself, but only if it does not conflict with the first and second law. I repeat, okay, first law says that the robot should not harm the human being either by action or by inaction. Okay, so first law is very easy to remember, and the second law is it says that the robots must obey the human orders. Okay, it should obey the human orders, but with those orders do not conflict with the first law. Okay, it should not conflict, okay, to the first law. It should also follow the first law. Along with that, what it says that it should robot must obey the human orders. Okay, along with following the first law. And the third law says that robot must protect itself, but only if it does not conflict with the first and second law. Okay, so third law is also very easy to remember, right? It must protect itself, following along with, okay, first and second law they have to follow, and the third law what it says that the robot should protect itself. So, right, very easy to remember these three laws. And these laws are classically ethical ideas in real industrial, okay, robotics. These are the applications which I'm telling, okay. So, in real industrial robotics, these ideas are converted into safety systems like emergency stop buttons, sensors, interlocks, okay, and the risk assessment. Okay, so the main point is human safety is always the highest priority in the robotics. Okay, I repeat, the main point is human safety is always the highest priority in the robotics. Okay, so you just include these points, and the next question is brief history of the robotics. Okay, so explain the brief history and the development of the robotics over the years, right? So, how you're going to explain this? Okay, the word robot was first introduced or used in 1921 in the play called RUR. Okay, and in 1942, Isaac Asimov introduced the famous law of robotics, and in 1942, George developed the idea of programmable manipulator, and in 1961, Unimate was used in the General Motors plant, which became one of the first industrial robots. Okay, and the later during the 1970, microprocessor, CNC machines, and sensors improved the robotic systems. Right, and today when we talk about the robots, okay, are used in industries, medical, surgeries, logistics, agriculture, space, and collaborative applications. Right, so robotics developed from simple mechanical machines to intelligent sensor based system. So very important, okay. So here you have to tell the history, okay. So how it was introduced, the word called robot, and over the years how it impact and how it developed over the years, what you have to answer to this question. So, okay, and the important point is very here is that the robotics developed from simple mechanical machines to intelligent sensor based systems. Okay, so this is what you can just remember this flow so that it will be easy for you to write in the sentences in your exam. Okay, so let's move to the next question, which is basic components and the block diagram. So I repeat again, if you have the hard copy of textbook, you can refer the textbook diagram. If not, you can also refer these diagrams for your exams. Okay, so this is very important diagram. Okay, here they are saying that explain the basic components of the robotic with a neat block diagram. So here is the block diagram which you have to remember in the flow. So your robot system mainly consists of program or tech dependent controller, drive system, actuators, manipulators, end effector, sensors, feedback, and system and power supply. Right? So here the controller is going to act like a brain of the robot, and the drive machine and the actuator create the motions, whereas the manipulator consists of links and joints, and the end effector performs the Okay, actual task like gripping, welding, and painting. Okay, so sensors is going to provide the feedback to the controller so the robot can correct its motion, right? And so in the exam, what you can do, you can just draw the diagram neat with the arrows showing the flow from the program to the controller, and from controller to the drives to the manipulator, and then to the task. Okay, so this is what you can remember for this question or for this specific topic. So moving on to the next is component function. So here you have to explain what specific component does. Okay, or what is the function of that specific component. Okay, so let's understand one by one. The manipulator, here you can see the manipulator is the mechanical structure made of links and joints, and the end effector is the tool or the gripper fixed at the wrist of the robot. And the third is drive and actuators. Okay, convert energy into the motion. They may be electric, hydraulic, or pneumatic. Okay, pneumatic. And the controller is going to store the program which calculates the motion and sends the commands to actuators, and the sensor is going to collect the informations like positions, force, region, and proximity. Okay, so the teach pendant is used to teach the positions, jog to the robot, edit programs, and start or stop operations. Okay, so this is the working sequence is from program to the controller, from controller to the drives to the manipulator, and then from manipulator to the end effector, and end effector to the task. Okay, with this sensor feedback, you can just write the functions for the each component. Okay, next is robot specification. So explain important robot specification. So the payload, what here payload means is it is the maximum load that the robot can carry at its wrist, including the gripper and the workpiece. Okay, reach means the maximum distance and the end effector that can move from the base. And next we have something called degrees, which means the freedom, the number of independent joint movements of the robot. And then work is the envelope in the 3D. Okay, work envelope is the 3D space within which the robot can operate. And then we have accuracy. Accuracy means how close the robot reaches. Okay, how it is going to reach the commanded position. And then we talk about repeatability, means the ability of the robot to come back to the same position again and again. And then resolution means the smallest movement of the robot, okay, it can detect or command. And then comes the speed, which tells or means how the fast robot joint or end effector can move. Okay, for selection of the robot, we can check the payload, workspace, precision, speed, safety, and cost. Okay, remember this point for this specific question. Next, we have us explain the No, sorry, we are done with this, right? So next we have is accuracy versus repeatability. So this is the commonly asked short note questions where you have to differentiate between the accuracy and repeatability. With the diagram you can remember this and explain the answer, okay, for this. So here accuracy means how close the robot reaches the actual target point, and repeatability means how consistently the robot reaches the same point again and again. Okay, and a robot may have good repeatability but poor accuracy. Okay, what I'm saying is the robot may have the good repeatability but poor accuracy. That means it reaches the same wrong point repeatedly. Okay, and a good robot should have both accuracy and repeatability. So in exam, draw the target diagram, show one case where the points are grouped together. Okay, here you can see grouped together but away from the target. Okay, away from the target, and another case where the points are grouped near the target. Okay, so that is what you can just draw the diagram and remember the points for the accuracy and repeatability. Okay, so next question is classification of robots. Okay, so now let us discuss the classification of robots. Robots can be classified based on configuration, drive system, control system, applications, and autonomy. Okay, based on configuration, robots are Cartesians, cylindrical, polar, Scara, and then articulated and delta robots. Based on the drive system, robots are electric, hydraulic, and pneumatic. Okay, based on control, they can be limited sequence, point to point, continuous path, or intelligent robot. And based on applications, we have industrial robots, medical robots, agriculture robots, space robots, and service robots. And when we talk about autonomy, we have manual, teleoperated, autonomous, and collaborative. Okay, so this is what you can remember. These are the classifications of the robot: configuration, drive system, and then we have applications, autonomous. Okay, autonomy. So this is what okay, you have to remember along with the example. Okay, what drive systems are the examples, and then configurations, what it consists. Those things you can just include in that. Next, okay, next we have configuration based classification. In this slide we explain the robot configuration. A Cartesian robot has three linear axis and rectangular workspace. It is used in gantry system. Okay, gantry system and the CNC loading. Okay, and the next is the cylindrical robot has the rotary base and linear movements. It gives the cylindrical workspace. And next we have the polar or the spherical robot uses rotary and linear motions and covers the spherical volume. And the Scara robot is a fast and horizontal movement and is mainly used to assembly the pick and place. Okay, and next we have articulated a robot which has the rotary joints like human arm and is used in welding, paintings, and material handling. A delta robot is very fast and used in packaging and sorting. So here you can just draw the classification tree and write one example for each type. Okay, next we have is human system versus robotic system. So this question is asked like comparing the human system and robotic system. So the human brain is compared to the robot controller. So human sense organs are compared to a robot sensor, and then human nerves are compared to cables and input output systems, and human muscles are compared to actuators. So human bones are next compared with the robot legs, and human joints are compared to the robot joints. Next, lastly, we have human hands and fingers are compared to the robot and effector. Okay, so these things you can just remember in the flow and write those things in the sentences. Okay, so humans are intelligent, creative, and adaptive. Robots are programmed or trained to perform the specific task. And where when we talk about humans, we say that humans are better for judgment and decision making. Robots are better for repetitive, hazardous, precise, and continuous work. Okay, so next we have robot safety measures. Now let us discuss robot safety measures. Before installing a robot, risk assessment must be done. A robot working area should have the fencing or the restricted zone where emergency stop button should be provided near the robot cell. And when we talk about the interlock gates should be used so that the robot stops when the gate opens. And when we talk about lights, so light curtains are presence sensors can detect if the person enters in a danger zone, right? And during the teaching mode, the robot should move at the low speed and the operator should use an enabling switch. Okay, and during the maintenance, lockout and the tag out should be followed, and also the operators must be trained properly and warning signs must be displayed. Okay, safety should be planned from the design stage itself. Okay, so this is about the robot safety measures. So these keywords you can just remember for this specific question along with the diagram. Okay. Next, we have social impacts of robotics. Robotic has many positive impacts, but it can increase productivity and improves the product quality. It reduces the hazardous work for humans. It improves the precisions in manufacturing, inspection, surgeries, and logistics. So robot also create a new jobs in robot design, robot programming, maintenance, and integrations. But there are some challenges also where robots may replace repetitive manual jobs. There may be skill gaps, so workers need reskilling, and then small industry may face difficulty because of high initial cost. There are also ethical, privacy, safety, and responsibility issues. So the balanced conclusion is that robotics does not simply remove the jobs, it changes the types of jobs. Reskilling is very very important. Okay, I repeat. So what I'm saying is the balanced conclusion is robots does not simply remove the jobs, it is going to change the types of job. So what is important? You have to reskilling. Okay, so reskilling is very important in this. Next question is robotics market and future prospect. Okay, so let us understand the robotics market and future prospects. The demand for robotics is highly increasing because of automation, artificial intelligence or AI, then sensors and machine vision. So robots are used in manufacturing, the healthcare, logistic, agriculture, space, defense, and domestic service. So in the future, collaborative robots will become more common, especially in small and medium industry, because AI and vision systems will make robots more adaptive, and also it is going to make it intelligent. So the soft robotics, medical robotics or agriculture robotics, cloud robotics, and service robots will grow further, right? It even in this space it is going to grow. In robotics create the opportunity in design and control, programming, safety, simulations, and system integrations. Okay, so these are the advantages and disadvantages which you can remember for the answer. Okay, so very important. So advantages I have written, disadvantages. Okay, so that's it for this video. Okay, and in the next video we are going to cover the module 2, module 3, module 4, and module 5. If you need the important questions for these 4 units, then you can just comment on this video so that I can make a video on module 2, module 3, module 4, and module 5. So that's it, and also I will tell you where you're going to get the notes for this specific subject. So you can just go to vtusmartprep.com, and then you have to create an account, and then you have to sign up, entering your name, email address, okay, and password. And once you enter sign up, you are going to get the confirmation mail, and then you have to confirm it. Once you confirm, then you will get the access for the particular notes, where you will, at the top right, you are going to find the menu called open elective. You can select that, and you can just select your open elective subject, and there you will find the notes. Okay, so that's it for this video, and do not forget to subscribe to my channel, and see you in the next video. Till then, you can just study the module 1 notes. Okay, so yeah.